Hi students, I've gotten several emails about this particular problem, and so I wanted to just touch base with you. I know the homework due date is past, but the emails were coming in 10 o'clock last night, and that's a little too late. But I still want you to get the knowledge, and so I want to talk to you about it. Okay, in this problem that has to do with this CrossFit trucking company, you read a clock cross and it says that what is this, the mean weight is now remember the numbers change, so let's say 6,000 pounds. They give you the standard deviation. It's a normal distribution. They tell you that 20 trucks are randomly selected. Now, all of this you are probably familiar with. This is, you're writing down, I hope, x bar or mu equals 6,000, sigma equals 145, and our sample size, right, is 20. Now, here's the difference. It says within what limits will 99% of your sample means occur. So when it says within what limits, they are of course asking you for the x value, the starting, low x1 and the high x2 values. And they're telling you that the area under the curve is 99%. Okay, so what's different is that typically you are given the x value, you convert x to z, you go to your z table, and then you look up a probability. But they gave you the probability. So you're going to have to go backwards. They actually call this a reverse lookup, because instead of having x going to z, then going from z to the probability, you have the probability. You're going to have to go to z and then go to x. The number one question that I've gotten is, what is this particular value right here? Whether, and remember these numbers are dynamically changing. So in this particular example, the value 2.58, and notice they're saying plus or minus 2.58. Well, 2.58 is the z value. Now, if we break this down, where does the 6,000 come from? Well, that's our mean. And so they're saying from the mean, I'm going to add on so much, and I'm going to subtract so much, and between those 2 points will be 99%. Okay? Now, hopefully that is starting to ring some bells for you. I know you're in your testing period, so I'm going to use a different example to demonstrate the concept. Okay, you have to apply the concept. Now remember, this is called a reverse lookup, and these are the Chapter 7 Part B slides that are out there in pause in the content area. And so it says, what if we were given the probability and not the x or z values? Okay, now in this example, and this is a great example of that, we have a tire company, and they wish to set a minimum guarantee. Okay, they want to say with great certainty, in fact, skipping ahead here, that no more than 4% of their tires have to be replaced. So we're given the probability. Now let me come up here and read through this. Okay, so it's the tire company. Tests reveal that the population mean is 67,900 miles on average for the tire, right? They know they have a sigma, a standard deviation of 2,050 miles. So in other words, this could go on up there, right? Was it 69, almost 70,000 miles? Or it could go lower. It follows a normal probability. Layton wants to set the minimum guaranteed mileage so that no more than 4% of the tires have to be replaced. What minimum guaranteed mileage should Layton announce? Now, believe it or not, this problem is just like your CrossFit trucking company, because we were given a percentage. Okay, so I'm pulling out the formulas. I'm listing my variables because I'm going to put values into the variables to see what I have and to see what I don't have. Well, as we've said, mu is 67,900. There's sigma. Now, typically you look through the problem and you're looking for x. There's no x, which means we can't convert to z, but we do have a probability of 4%, or well, I should say a percentage. The probability would be 0.04, right? So 0.04 is the area under the curve. Okay, so hopefully you're doing this same thing where you're writing down the formula and you're listing your givens. Okay, these are givens, and you're putting, when I say list them, you're putting them next to a variable. That makes it easier when you get ready to do your work. Now, here's another step that students try to rush through, and I think what you're probably going to find is you can either spend 30 seconds doing this now, or you can spend 45 minutes getting it wrong because you think you've got it right in your head, but when you put it on paper, you start to say, oh, I understand. Okay? For example, they said that this particular problem, just like your cross-it trucking problem, follows a normal distribution. Now, this is our standard normal curve up here, and this is the z-axis. This is typically what we convert everything to. I'm going to start down below this with the x-axis. They told us that the mean, the population mean, was 67,900. That's on the x-axis. On the z-axis, the mean goes to 0. We put everything at 0, right? Okay, what is this showing? This is showing that on a standard normal curve, 50% of the area, which is probability, is to the left, 50% of the area is to the right. Remember, 100% under the entire curve, it's symmetrical, so 50% to the right, 50% to the left. These are things that we know. Now, they've told us, what have they told us? They've told us 4%, let me see if that's the next thing, is what we're going to replace. So in this particular case, now this is a little different than your cross-it trucking company, and I'll talk about that, but they told us we're going to replace 4%. Part of labeling your picture is deciding where that probability actually occurs. Well, if we're going to replace tires, we're only going to replace the bottom ones. We wouldn't replace the ones that lasted all the way up until here, or that died somewhere here in the middle, right? Now think for a second about your cross-it trucking company example. They specifically talked about the middle 99%, didn't they? So the labeling of your picture would be different. In this case, 4% is down here. Cross-it trucking, 99% centered, half on this side of the mean, half on the other side of the mean. But you're drawing your picture and you're labeling it, right? Now, back to the similarities. I think I have some more percentages. Let me label those. I would ask you what this percent is. Well, you already know that from the mean all the way to here is 50%. So that means this is obviously 0.46, because 0.46 plus 0.04 equals 0.5. Okay. Now, what we don't know is the z-value. How can we find that z-value? Because we need z in order to get to x. Now, in this case, just like cross-it trucking company, you have a percentage from here to here. Actually, the 99%, remember, is half. This is half, and then the other half, and you still don't know z. Well, we need z, so let's go to our table. Okay, here is your z table. And the way this works, and you got to listen to me now because this is where you get confused, is you're probably taking that 99% and trying to find it under this z. Why are you doing that? You've never done that before. Z is not a percentage, it's not a probability. Here in the middle, these are your probabilities, right? You use the z to get to the probability. This time we had the probability, so we're going to have to use the probability to get to the z. Okay, in our example, I'm going to stick to one example at a time here. Remember, we just said that that z value, according to our table, is always found from the mean out to the point. I don't want to look up 4% because that's not what the table is expecting. The table says go from I thought I had the picture here. In your book, you'll see a picture at the top, and it says go from the mean to, which is the starting point, to some stopping point. Okay. I think I might have gone off my screen here just a little bit. But if we come down here, if you can still see this at the bottom, see my arrows going by, 46%, 0.46 is someplace in here, in between 0.4599 and 0.4608. So what we're going to do is we're going to go across. I've tried to change the view here to let you be able to see. 0.46, which in our tire example is what we're looking up. Let me go back for just a minute because it starts from here and goes to here. So 0.46 from the mean to our cutoff point. Okay, well, that's a probability, so I'm going to look in the middle of the table. I couldn't find exactly 0.46, but the closest area is right here between 0.4599 and 0.4608. So I'm going to go across and say that my z-value is 1.75. See how that works? 1.75. Why did I pick 5 instead of 6? The reason that I picked 5 instead of 6 is because 0.46 is closer to 0.4599 than it is to 0.4608. Go to whichever one is closest. Okay, now I've got this z-value. What do I do with the z-value? Let me go back into my PowerPoint mode so we can see this again. We've decided that z is 1.75. We know this